Okay, so we continue the lesson. So, dear, if you remember, we started talking about sequences. There are two sequences that we are interested to learn about them in this course. One of them is called arithmetic progression, which will be the topic of today's lesson, and the other one will be geometric progression. So what do I mean by an arithmetic progression? I think this is not completely new to you. If you remember, you learned this topic in Math 1C as well, okay? But let us just forget about that. We start from scratch here, okay? So what is the meaning of what is the definition of an arithmetic progression? It's very simple. I have a sequence so that each term of the sequence is obtained from the previous term by adding a constant term to it, a constant number to it. Yes. For example, I have this sequence A1, A2, A3, etc. And then I have a fixed number which is denoted by D, and it is called the common difference. This is a fixed number. I take that fixed number, I add it to A1, I get A2. I add it to A2, I get A3. I add it to A3, I get A4, and so forth. So that is called an arithmetic progression. The simplest possible arithmetic progression probably is 1, 2, 3, 4, 5, etc. So that is an arithmetic progression. When I put these dots, I mean that the pattern will continue. So the common difference here is 1, yes? Because I am adding 1 to each term to get the next one. So here, this is an arithmetic progression in which the common difference is 1. There is no limitations for the common difference, but usually one value is not very interesting. What is that value? You can, in principle, have any value that you want for the common difference, but one value generates a sequence which is not that very interesting. Yes? 0. Because if you take D to be 0, it means that you generate the same constant term all the time. So usually we prefer not to work with D equal to 0, but there is nothing wrong about 0. Yes? So if I have D equal to 0, so for example, is it an arithmetic progression? The answer is yes, but in this case, the first term is a square root of 2, the common difference is 0, which actually is not that interesting. For example, if I want to answer any questions regarding to this sequence, you really don't need to know any knowledge about this. For example, if I ask you what is the 100th term of this, the answer is simple, square root of 2. If I ask you, if I add the first 100 term, what will be the sum? It is easy, you multiply 100 by this. So answering these sort of questions regarding this sequence is very simple. This is why we usually think that D is not 0. But what about this one, for example, 5 minus 3 minus 11 minus 19. I hope that you agree that if this pattern continues, this is also a geometric, an arithmetic progression. What is the difference here? What is the common difference? Minus 8. I am adding minus 8 at a time to each term to generate the next term. Yes? So this is also an arithmetic progression. So it can be negative. It can also be, for example, like this. I have 1, and then I have 1.5, then I have 2, then I have 2.5, and etc. You see that the common difference here is a fraction. Yes, so any number that you can imagine can play the role of the common difference, and it will generate a sequence for you. So in order to understand, in order to know the arithmetic progression, 2 pieces of information is enough. Yes, if I know where to start, meaning the first term, and if I know the common difference, then I can generate the whole sequence. So 2 pieces of information is needed to generate any arithmetic progression. So A1 and D are the main questions when it comes to an arithmetic progression. Okay, if I want to write a generic formula for D in an arithmetic progression, I would say that D is any term, say term number n, minus its previous term. So that is clear. Any term, say nth term, minus its previous term, n minus first term, it becomes the common difference. So it doesn't matter where you start. If I take the difference between these two is 1. If I take the difference between these two, is also 1. If I take this one minus that one, it becomes minus 8. If I take this one minus that one, again becomes minus 8. Okay, the first thing that comes to mind is that can I find a generic formula for the nth term? So assume that you have a sequence, you have an arithmetic progression, I give you A1, and I also give you D, and suddenly I ask you what is term number n? What is the general term? Okay, we want to discover the formula, yes? So we'd say that, okay, A1 is equal to A1. But if I ask you what is A2, you will tell me, based on definition, it is A1 plus D. Yes? If I ask you what is A3, is A2 plus D. But A2 itself is A1 plus D, and then I have another D, so this becomes A1 plus 2D. Yes? And I want you to find a pattern to be able to guess. Of course, if you want to be very rigorous, you have to prove it, but the proof is related to mathematical induction, which we haven't studied yet. But that is not very hard to convince yourself that this pattern will continue. So if I ask you what is A4, you will tell me A4 is A3, the previous term, plus the common difference. But in the previous step, I found what is the A3. So instead of A3, I replace it with A1 plus 2D. Then I have another D here. If I simplify it, it becomes A1 plus 3D. And I think now that the pattern is clear, yes? So if you want to keep the consistency, if you don't mind, let me also add 0 times D here. The reason that I wrote it here, because I want you to see the pattern is continuing. So here you see I have A1. In this one, I also have A1. In this one, I also have A1. I also have A1. So hopefully you can guess that if I continue this process, AN starts with A1. And then another term is added to A1. Okay? Here, if your index is 1, the coefficient is 0. Here, if the index is 2, the coefficient is 1. And the index is 3, the coefficient is 2. Index is 4, the coefficient is 3. So you can guess that if the index is n, the coefficient is n minus 1d. So that is one formula. That is important for our lesson. So that is the first formula in an arithmetic progression. So if I give you A1, if I give you D, I can ask you about all the terms in the sequence. And then you can use this formula, which is of course given in the formula sheet, and then calculate that. Yes? For example, if I give you this sequence minus 5, minus 15, minus 7, and then 1 and 9, etc. I'm telling you that this is an arithmetic progression. Okay? I give you this and I tell you this is an arithmetic progression. Am I done it right? Yes. And then I will ask you what is the 20th term of this. So I'm asking you what is term number 20. Okay, so the answer is easy, yes? So if I want to answer what is term number 20, of course, one way is to continue this list to see the 20th term is what is the number for the 20th term, but that is not the goal. I could ask you what is the 100th term, yes? You can, of course, if you are patient, you can continue 100 terms, but it is better to do it using the formula. So the formula is on the board. This 20 is playing the role of this index n. What is A1 in this problem? You can immediately see it. What is D in this problem? D is any number that you choose, for example, -7, minus its previous number. It doesn't matter where you start to do it. So this becomes -7 plus 15, which is +8. So it means that I can put this into the formula. A20 is A1, which I can read it directly, plus 20 minus 1 times D, which is 8. And then I calculate this. So it is -15. This is 19 times 8. What is that number? 160, 152, yes. And then I subtract them, it becomes 137. So this is the answer to this question. The term number 20 is 137. Yes? For example, I can ask you which term if any is equal to 225. Yes? Okay, so how should I answer this question? Which term means the number of the term is relevant for me. It means that I am asking you about this index. So this means that which term an is 225. So that's different questions. Yes, they can give you the sequence and ask you find a particular term. You just put the information in the formula. They might ask you which term is equal to this given number. This means that they are asking about n. Okay, so you know an is 225. You don't know the number of the term, but you know that according to the problem, if any, there should be a term with 225 be equal to 225. I want to find which term is that. Okay, again, I have the formula in front of me. So instead of an, I write a1 plus n minus 1d equals to 225. And then instead of a1, I put -15. N is missing for me, but I know that d is 8. And then I have to solve an equation and find n. It's very simple, by the way. The questions in this section is very, very simple. It becomes 8n minus 8 minus 15 is minus 23 is equal to 225. Yes, so 8n becomes, I add 23 to this one, it becomes 248. Yes?
Where did you get minus 23 from?
I multiplied in 8n minus 8 minus 15 is minus 23. Okay, and then what is n? Not 61, 31. Yes, so it means that if you continue this list, when you reach to term number 31, you see the number is 225. So these are very standard and simple questions they might ask you about arithmetic progression. Okay, for example, another one. So example, so in an AP, let me write for short, arithmetic progression. In an AP, we know that so we have these information. We know that a number 4 plus a number 11 is equal to 105, and a number 3 plus a number 7 is equal to 80. Okay, determine the AP. What do I mean by determine the AP? It means that write the sequence. But of course, you know that writing sequence is not a good idea. What I need to present is the first term and the common difference. Because if I know the first term and the common difference, you can generate the whole sequence. So when I say determine the AP, indirectly I am asking you to find A1 and D. Because by knowing these two, you can answer all sorts of questions regarding your AP. Yeah, I think this is also very simple, isn't it? So I know I have an arithmetic progression with these properties that if I take the fourth term and add it to the term 11, it becomes 105. And in the same arithmetic progression, if I take the third one and add it to the seventh term, it becomes 80. I want to understand which sequence, which arithmetic progression has that property. Okay, so what I do, I will start from here. But I have that formula. Instead of A4, what can I write? I can write the first term, but plus how many D's? One less. Yes, I have index 4. The index that appears, the coefficient appears is n minus 1. So if I have 4, it becomes 3D. This is what I write instead of A4. And then instead of A11, what can I write? I can write again A1 with 1 less, which is 10D. And then this is equal to 105. I simplify this a little bit. I have one A1 here, another A1 here, so this becomes 2A1, and then I have 13D is equal to 105. So I cannot solve this because I have two unknowns, but I have still one equation. This is why they have given us one more equation. But the idea is clear. I will write this down and use the same method. So this becomes A3 plus A7 is equal to 80. Instead of A1, I write A1 plus 2D. Instead of A7, I write A1 plus 60. And this is equal to 80. And A1 plus A1 is 2A1. 2D plus 60 is 8D is equal to 80. That is the second equation. Yes? And then you have two equations and two unknowns. So you set up a system to solve for A1 and D. Okay, so I solved the system. How? For example, I multiply the lower one by a negative one. Let us do it in our head. If I multiply this, it becomes minus 2A1, and then I add it to this one. These two will cancel. And this becomes minus 8D. When I add it to this, it becomes 5D. And I multiply this by minus sign, becomes minus 80, and I add it to it, it becomes 25, yes? And then I'm looking for D, so D becomes just 5. And now when I have D, I put it in this equation with the smaller numbers to find A1. It doesn't matter if you want to put it here. But if I put D here, 8 times 5 is 40, and I move 40 to the other side, it will be 40 again, and I divide by 2, so A1 becomes 20. Yes? So this is very simple, so let us not waste time. So A1 is 20. Another example is simple, but it is good to know, is this one. The following is an AP. So the numbers are 40, 47, 54, up to 208. So it's a finite sequence. I start from 40, and I am probably clear. What is the common difference? Is 7 at the time. I am adding 7. According to the problem, I will reach to 208 at some point. Now the question is that how many terms you see in this list. Okay, so the following is an AP. How many terms are there? So that's also a good question. It is very simple, but I want you to understand that if you have a list of numbers that you can see, it is forming an arithmetic progression. And if you have the first term and the last term, you should be able to tell me how many terms are involved. So how should I answer that? Yes?
I would look at the first, or like the general formula.
Yes.
And then I would, if we have A1, which is 40, and then we also have the last term, so I would set AN as the last term.
Exactly. So that's what you are saying. So that is actually telling you we can consider this the first term, the second term, the third term. I don't know which term is that, so I call it term number n. N is missing. That's more or less the same question as we had before, formulated in a slightly different way. So what we can say is that, okay, so this is my first term. According to the problem, that is an AP, so I need to find D, which is, I take these two consecutive values, 47 minus 40, for example. This is 7. And then I write the formula that AN is A1 plus N minus 1D. Instead of AN, the whole AN is 208. A1 is 40. N is missing. D is 7. So I move this to the other side. It becomes, I can simplify it if you want to. It doesn't matter how you solve the equation. So it becomes 7n minus 7 plus 40, which is 33. And then what happens? I move 33 to the other side. It becomes 5, 7, and 5 is equal to 7n. Am I right? Yes, so and if you divide this number by n, by 7, what do you get? 25. So this means that in this list, there are 25 numbers involved. Any questions here? The questions are very simple, actually. Let me just solve another one. So I write three terms here, a squared plus 2, and then a squared plus 8, and then 12a minus 6. And then I will write some dots here. My question is that I want you to find this missing A so that this forms an arithmetic progression. Okay, so we don't know. I only have just one piece of a long sequence, probably, the first three terms, but I want to fine-tune this unknown A so that this list becomes an arithmetic progression. So what should I do? For example, if I choose, let me choose 0. If I choose 0, the first number becomes 2, the second number becomes 8, then third number becomes -6. But do you see that this is not an arithmetic progression? Because it is increased by 6, then suddenly it has decreased. So it is not an arithmetic progression. I don't want to do trial and error. I want to fine tune this A so that if I replace A with that number that I will find, then this forms an arithmetic progression. So how should I solve the problem? Because algebra involved is very, very simple. But the idea, you need to find it out. So what should I do?
Maybe you could equate the second term to the first term.
Not equate. Why should I equate?
No, I mean, you put the second term into the general formula.
Yeah, that is possible, but might be that is a little bit harder way to do it. Any other? Yeah?
Well, if you put 8 plus 2 plus d equals 8 to the power of 2 plus 8, and then you solve for d, you have to also take the past.
Yeah, so it means that, so this means that the difference between these two should be equal to the difference between these two, because I have one unknown, so I need one piece of information in principle to be able to find that, and that is my piece of information. Because if this is supposed to be an arithmetic progression, it means the difference between these two should be exactly the same as the difference between these two. Yes, so it means that if I take this and subtract the previous term from it, it gives me D. But I don't need to write it D, but I know that whatever this difference is, if this is supposed to be an arithmetic progression, it should be equal to the difference between these two terms, yes? Yes, do you agree? So this is the meaning, but this is simple now, because if I remove the pairs of brackets, I will get this minus a squared minus 2. On the right-hand side, I will have 12a minus 6 minus a squared minus 8. And this one and that one are canceled, so this is just 6. And here, I have 12a minus a squared minus 14. And this is a quadratic equation, so I move this to the other side. For example, this becomes positive a squared minus 12a and then positive 20 equals to 0. You can use PQ formula or ABC formula, or now because you are grown-up students, probably you can factorize it. It is easier, yes? Can you factorize this? Factorization, if comes to mind, is the easiest way. So if I want to factorize this, I would write it as like this, and I ask myself, can I find two numbers, two integers, so that the sum is minus 12 and the product is 20? I don't think it is hard to find. You don't have to do it in that way. You can use PQ or ABC formula to solve it. But I mean, this is faster. Can you guess those numbers? Yes?
Minus 2, minus 10.
Minus 2, minus 10. Yes? So it's minus 2, minus 10. The addition, the sum is minus 12. The product is 20. And this is equal to 0. So this means that either this is equal to 0, which means a is equal to 2, or this is equal to 0, which means a is equal to 10. So this means that a is equal to 2, or a is equal to 10. Do you think both of them are acceptable, or one of them is acceptable, or what? Both are acceptable. What will be the difference, do you think? Let us check. If I put 2 here, the first number becomes 6. The second number becomes 12. And the next number becomes 24 minus 6, which is 18. That is correct. Yes, 6, 12, 18. What is the common difference? 6. If I put 10, what will happen? This becomes 102. This becomes 108. And then this becomes what? By the way, is it? Yeah, that's acceptable because this becomes 120 minus 6 is 114. Yes? So you see that both of them are acceptable. Here, 6, 12, 18 is actually one part of the arithmetic progression with common difference 6. Here, the common difference is still 6, but this is 102, 108, and 114. Yeah, so both of them are acceptable. Okay, if I want to improve, if I want to make it a little bit harder, we can have this question, and I want to wait for you to solve it for me, okay? So here I want you to determine A and B such that the following list is actually part of an arithmetic progression. The list is A plus B and 2A plus B plus 1. And then you have 3B plus 4A minus 2. And then you have 5A plus B plus 1. And then of course this list continues. Now I'm asking you to fine-tune this A and B such that when you look at the whole sequence, it forms an arithmetic progression. So more or less this is the same lesson, this is the same question, but now instead of having one single unknown, I have two unknowns. Then of course you expect me to give you more pieces of information. This is why I have provided for you 4 first terms rather than first 3 terms. Yes? So I pause recording, I will try to wait for you a little bit. And if you have your final answers, you can read it because now I can see in the book the answers are in front of me. No answers yet? Yes?
Is A equals 2 and B equals 1 an answer?
A is equal to 2 is correct, but your B is wrong, I think. According to the book, A is 2, but B is not what you said. You said 1.5 or something? 1. No, B is not 1. A is 2, B is 3. So let us calculate this to see how it goes, because I want to teach you also a little bit more. So B and AP, okay? Okay, so what, I don't know how did you solve the problem, but the idea is the same, yes? The difference between these two is equal to the difference between these two, and the difference between these two is equal to the difference between these two. Yes, so that's the idea. Okay, so what can I do? I can say that, okay, this 2A plus B plus 1 minus A plus B is equal to this minus that, which is 3B plus 4A minus 2 minus 2A plus B plus 1. Okay, this is one condition. But let me simplify this as much as we can. Let us just do it in our head. Minus A and 2A is just A. Minus B will cancel that B. I am left with this A plus 1. On the right hand side, if I multiply minus sign in, minus 2A and 4A becomes 2A. And then minus B and 3B is 2B. And then I have minus 1 minus 2 is minus 3A, minus 3. And then I can simplify it a little bit more. For example, if I move these to the left, and then I move this to the right, so it becomes minus 4. So this is one equation. Yes. And then I do the same thing for the other two. So what did I consider? I told myself that the difference between these two is equal to the difference between these two. I can go one step more. I would say that the difference between these two, on the other hand, should be equal to the difference between these two. Yes?
In the equation you just made, you could just multiply everything
By minus sign. I kept it like this because I don't know what will happen in the future. Might be I have to multiply it again by minus. So here I will take the difference between them. It's equal to the difference between these two, yes? So 5a plus b plus 1 minus 3b plus 4a minus 2. And then I start simplification again. So minus 2a to 4a is positive 2a, minus b 3b is 2b, and then minus 1 minus 2 is minus 3. On the other side, I have 5a minus 4a is a, and then I have b minus 3b is minus 2b, and then 1 plus 2 is 3. Okay, so I move these to the right, to the left, and this to the right. So this becomes a plus 4b. On the right hand side, I have 6. So now you see that it was better that I didn't multiply because I need the minus sign, yes? So here I make a system. Minus a minus 2b is equal to minus 4, and then I have a plus 4b equals to 6. So if I add them, so you are right, b is 1. Because if I add them, it becomes 2b is equal to 2b is 1. And then if b is 1, a is 2. I don't know, because the answer in the book is different. Or might be I have written something wrong when I wanted to copy and paste the question from the book. Or we can check, by the way. Because one equation they get is minus a plus 2b is equal to 4. So
the equation is different.
The equation is different. Now, but let me see. Do you see any flaws in my calculations? So might be it is easier to plug the numbers in to see if it works or not. This works? Okay, so let me put, instead of a, I put 2, instead of b, I put 1, it becomes 3. And the next one is what? 4 plus 1, which is 5, plus 1, which is 6. Yes? And if I put here, it is 3 plus 8, 11 is 9. So it is working apparently, but let me make the last one. So 5a is 10, 11, 12. So yeah, that's correct. Yeah. So might be I have written the question wrong. I'm not patient to see it. Yes. But what I have written on the board is correct. You see, when I solved the problem, I found a and b, I plugged them back here, and then I hope that you agree this is an arithmetic progression with the common difference 3. 3, 9, 3, 6, 9, 12. So that's correct. So what you have written on the board is correct. Okay. Any questions? So that is something you see that this is not hard, by the way. And let me just draw your attention to one nice relation, because this book is using this relation to solve it. Of course, it is consistent. You shouldn't get a different answer, but that is good to know. If I have 3 consecutive terms, okay, 3 consecutive terms of an arithmetic progression, 3 consecutive terms, not necessarily from the beginning, but 3 consecutive terms of an AP, there is a really nice relation between them. The one in the middle is the average between these two. Okay, so that's a good relation to know. If you have an arithmetic progression, if you look at 3 consecutive terms, it doesn't matter if it is at the beginning, in the middle, or in the end. So you have 3 consecutive terms, then the middle one is the average between these two. Or, in other words, 2 times the middle one is a plus c. The book is actually using this idea to solve the problem, but it shouldn't give me the different answers. So why this formula is correct? Why this relation holds? Yes?
Because all of the three numbers have the same difference between them.
Yeah, so it means that B, if I want to go from B to A, I have to write B minus D. If I want to go from B to C, I have to write B plus D. So another name for A is B minus D, where D is the common difference. Another name for C is B plus D. So and then it's clear that if I add the first one to the last one, if I add these two, it becomes 2B, which is 2 times the middle. So this is a good idea to remember if you have an arithmetic progression and if you have 3 consecutive terms. The term in the middle is the average between the terms on the sides. Okay, there's another question here that's also good. I give you -7 and I give you 23 and I ask you to find 5 numbers in the middle so that when you look at the whole sequence, it becomes an arithmetic progression. Is the question clear? So I'm asking you to insert 5 numbers between these. I can ask to insert 3 numbers in the middle, 10 numbers in the middle. So now I'm asking you, insert 5 numbers, 1, 2, 3, 4, 5. I'm asking you to insert 5 numbers between these two so that when you look at the whole sequence, it becomes an arithmetic progression. Okay, so I want to wait for you to solve it. Okay, any ideas? Yes, do you have your numbers, Robert?
Yes.
Yes, what are they?
-2, 3, 8, 13, 8.
13, 8. Yes, that's correct. So how we solve the problem, it is very simple because I'm supposed to insert 5 numbers here. So then it means this is my first term and this is my 7th term, yes? Because if I want to put 5 in between, this is 1, this is 5, so in total 6, so that would be number 7. Yes, so this means that this is a sequence, so it's an arithmetic progression where this is A1 and this one is, let me write it here, so this is A1, but this one is A number 7. So this means that I have given you A1 and I have given you A7. And then you want to find D, because D is enough for you. Because if you know D, you can add D to this one, you get that one. And then when you have this one, you add D to this, you get the next one, and then etc. etc. So okay, A7, so the problem is very simple, yes? A7 is 23, but you know the formula for A7 in an arithmetic progression. It is the first term plus 6 times D is equal to 23, but A1 is -7. Plus 6D is equal to 23. So 6D is 30. And then what happens for D? D is 5. Yes? So I realize that D is 5, and then the answer is simple. I add 5 to this becomes -2. I add 5 to this, it becomes 3. Add 5 to this, it becomes 8. Add 5 to this, it becomes 13. 5 to it, 18. And if I have done everything right, when I add 5, I have to reach 23, which is correct. So the numbers that I were asking you about are these numbers. Yes? So this method, you can actually increase the numbers in the middle, making the guesswork harder, but still systematically you can solve the problem. Okay, the last part of this lesson is finding the sum of an arithmetic progression. Okay? Yes?
Can an arithmetic progression be infinite?
Usually when you say progression, it means that it will terminate some point. Otherwise, you call it arithmetic sequence. Yeah. Usually you don't have that in our lesson. So here now we want to talk about an important part, which is probably the most important part of this lesson. If we want to find the formula for the sum of an arithmetic progression. the sum of the terms inside an arithmetic progression. And by the way, so there is a story which is actually true, and then one day, so Carl Friedrich Gauss, so he's a German mathematician, and he's called the king of mathematics. So he was a brilliant guy. So this problem is actually probably is true. I have read it in the history of mathematics. So I don't know, the first grade he was, or whatever, 6 years old, 7 years old. So the teacher came into the class. He wanted probably to make the students busy to do some work, and then ask the students in the first grade or second grade to add numbers from 1 to 100. Okay? And then he was thinking that this will keep these people busy for a while, but then I think 2 minutes, 3 minutes, 5 minutes later, Gauss actually answered the question. Okay, and then the method that he used to answer this question is exactly the method that I will use to prove the formula for the sum of the arithmetic progression. Okay, so what he did, let us keep it up to 99 because it makes this a little bit smoother. So the goal is to add 1 to 2 to 3, and I want to continue this list to 97, 98, and 99. Okay, you can also add 100 at the end if you want. So what he realized that at the age of 6, it doesn't matter if I add them in this order or I reverse the order and add them. Yes, if this is going to be S, call it for sum. If I add the numbers from 99 to 1, that would be the same number, yes? So everyone agrees that if this is supposed to be S, which is still missing, this sum is also S. Yes? And then he realized that if you add them side by side, S to S, another S becomes 2S. But the point is that when you start adding them, because addition is commutative and associative, it doesn't matter how you group them or how you reorder them. So I can add these pair first, which becomes 100. Yes? And then I can add these pairs, which becomes again 100. Yes? And then I can add these pairs, which becomes 100, and then you realize that this pattern continues so that I reach to these two pairs, it becomes 100, and these two pairs is 100, and then these two pairs becomes 100. But then adding a bunch of 100s is actually extremely simple, but you need to know how many 100s are involved. Yes?
100.
No. Yes? 99, because it starts from 1 up to 99, yes? So there are 99 100 involved, so 99 times. So the answer becomes very simple, because adding 100 to itself 99 times is simply multiplying 99 by 100, which becomes 9900, yes? But this is not the number that we have to present, because this is 2 times the number we are supposed to calculate. But if I know two of that, so I can find S by dividing this by 2, which is 4,950. And of course, if you want to add from 1 to 100, you can add 100 to it, which becomes 50/50, yes? But anyway, this is the method he used to answer the question very fast. And that is the exact method we want to use, but of course our problem is a little bit harder, because here, this is an arithmetic progression. Do you agree? 1, 2, 3, up to 99. The common difference is 1. But what happens is the common difference is just D, not 1. We want to answer this question. So I have an arithmetic progression which starts from 1, and then go to 2, then go to 3, A3, and assume that I continue this list until I reach to number n, an. My question is that, is there any formula that I can write for S of these? So this is A1 plus A2 plus A3, and then I can continue until AN. So the question is that I want to answer I want to discover a formula for this sum in terms of A1 and D. And because I want you to somehow show that this S depends to the number of terms, I put an index n for this one as well. Yes, so what does it mean? Whenever you see Sn in this topic, it means the sum of the first n terms. Yes, not any n terms. It is the sum of the terms from the first term up to the nth term. If you want to calculate this sum, that is called Sn. I want to find, my goal is to find the formula for Sn so that if I give you A1 and D, you can calculate Sn. That is the goal. Okay, I will use the same method. Okay, so what I do, so if you don't mind, let me write Sn here. So this is A1 plus A2 plus A3. And I want to continue until an to understand the pattern. What is the previous one is an minus 1. What is the previous one is an minus 2. Yes? And then again, I use his method. So I reorder them. I add them from that to this. So it becomes an plus an minus 1 plus an minus 2. And then I continue here. I will reach to A3, yes, what is that? Yes, A3 plus A2 plus A1. So you see I'm using exactly the same idea, and then I add these two, so this becomes 2Sn. But then the algebra is a little bit more involved. So I take this one and that one and put them in one group. Yes, I take these two and put them in one group. Take these two and put them in one group. And then I continue these two. Yes, this happens. In the case of this problem, it was extremely simple to see all of them are equal to 100. But here, apparently, they are different because the first sum is a1 plus an. The second sum is something else plus something else. Instead of a1, I have a2. Instead of an, I have a sub n minus 1. Okay? And the same story here. So it seems that I am doing the same thing, but the point is that, do you think that this sum, even though the terms are different, I'm claiming that all these sums are exactly the same number, even though they are different apparently, because I told you a1 and a2 are definitely different if d is not 0. An and the previous term was also different, but my claim is that in total the sum here and the sum there and the sum of all others remain the same. But why is that? So I hope that you understand that what is the difficulty of the new problem, yes? We have to convince ourselves. In the case of Gauss, it was clear, it was in front of our eyes that everything becomes 100. But here it is not that easy, yes, but I want to convince you that all of these sums are the same. Okay, to prove this, I would tell you this. If I have M and N and P and Q, so assume that these are natural numbers, so that M plus N is equal to P plus Q. M, N, P, and Q are all natural numbers. And assume that the sum of these two is equal to the sum of these two. My claim is A sub M plus A sub N is also equal to A sub P plus A sub Q. Yes? So let me tell you this to understand this better. For example, let us just write a random arithmetic progression to understand the content of this claim. So for example, let me start with 2, and let me have 3 as the common difference. So the next one will be 5, the next one will be 8, the next one 11, 14, 17, 20, 23, etc., etc. Okay. Okay, so this tells me that this term is term number 3, this term is term number 5. Yes? What is 3 plus 5? Is 8. Yes? Now let us choose another pair whose sum is 8. For example, can you tell me, for example, 2 and 6. 2 and 6 is also 8. Now look, what is the second term? This is my second term. What is my 6th term? Which is 17. Yes? Now add 5 to 17. What is the answer? 22. Add 8 to 14. What's the answer? 22 again. Okay, so that is the whole pattern I want to prove. It means that if you just choose 4 numbers, 4 natural numbers, so that the sum of one pair is equal to the sum of the other pair, if you go and look into the sequence for finding those terms, the same thing happens between the terms themselves. Yes? Is the idea clear or not? For example, if you want, we can test another one. So let me just increase it to 26, 29. For example, let me take 2 and 7. Yeah, 3 and 6, for example. Okay, the sum of 3 and 6 is 9. Give me another pair whose sum is 9. For example, let me just 2 and 7. 2 and 7 is also 9. So this means 3 plus 6 is equal to 2 plus 7. This claims that a number 3 plus a number 6 is equal to a number 2 plus a number 7. Yes? Let us double check. A number 3 is this number. A number 6 is, this is number 3. So A1, A2, A3. A4, 5, 6. This is A6. Yes? And then if I have A2, which is this one, and A7, which is that one. A2 plus A7 is 25. A3 plus A6 is also 25. That's always happening. So this is the claim. I haven't proven it for you yet, but this is the content of this claim. Is that understandable? Okay, but why this is true, it's very simple. So if I ask you what is AM plus AN, instead of AM, you can write A1, sorry, A1 plus M minus 1D. That is the formula for AM. If I ask you what is AN, you would say it is A1 plus N minus 1D. So this is the right-hand side. Okay? So what happens? This A1 and A1 becomes 2A1. And then I can factor a D out between them. So it becomes M plus N minus 1 minus 1, which becomes M plus N minus 2. Yes? So this is the right, oh, sorry, this is the left-hand side. Let me calculate the right-hand side as well. So this is A sub P plus A sub Q. But A sub P means A1 plus P minus 1D, yes? And then A sub Q is A1 plus Q minus 1D. But again, A1 plus A1 is 2A1, plus I factor a D out. So this becomes P minus 1 plus Q minus 1. So it becomes P plus Q minus 2. Yes? So this is the left-hand side. This is the formula I got for the left-hand side. This is the formula that I got for the right-hand side. Now I have something, I have assumed that this sum is equal to this sum. And I hope that you agree that then these two become equal, yes? Because this part is exactly copy-paste of this part. and then this is the same. So then what happens is m plus n minus 2, this is p plus q minus 2. But if m plus n itself is equal to p plus q, then these two are equal. Yes? So anyway, now how this is going to solve my problem? Because what is the sum of these indices? 1 plus n. What is the sum of these two indices? Let me write. The sum of the indices is 1 plus n. The sum of these two indices is 2 plus n minus 1. The sum of the next pair of indices is 3 plus n minus 2. And this list will continue. Do you agree? But all of these sums are equal, because 1 plus n is 1 plus n. Here I have n minus 1 plus 2, which becomes n plus 1 again. Here it's n minus 2, but plus 3, which becomes n plus 1 again. So all these indices are the same. So this means a sub 1 plus a sub n is equal to a sub 2 plus a sub n minus 1 is equal to a sub 3 plus a sub n minus 2, and this list goes forever. So it means that all these numbers are the same number. So what does it mean? It means that instead of this, I can write this. Instead of this, I can write this. Instead of this, I can write this, and it continues. So you see that all the contents are the same, even though they are apparently different, but all of them are the same. How many of them are there? How many of these terms we have? How many of them we have? N, because I had n terms from 1 to n. So this becomes n times a1 plus an. Yes, but I am looking for Sn, so I divide everything by 2. So Sn becomes n over 2 times a1 plus an. Yes, so this is the formula for Sn. Okay, so we found the formula for Sn, but I told you that I want a formula in terms of A1 and D. This is not a bad formula, by the way. I think both of them are given in the formula sheet. But if you want to continue, you can replace the formula for An here. So then this becomes equal to n over 2, A1 plus, instead of An, I write A1 plus n minus 1D. And this A1 and A1 becomes 2A1. So this is another formula usually written in the books. So I have n over 2, but then I have 2A1 plus n minus 1D. I think both of them are useful to understand. But remember, this is not just the sum of n terms. This is the sum of the first n terms. So in this language, this becomes the first term, this becomes the last term. So this tells you that if you want to find Sn, add the first term plus the last term, divided by 2, multiplied by n. But if you have A1 and D, and if you want to answer the same question, you have to use this formula. So actually these two formulas are one formula, and together with the formula of An, it is just the only formulas we need for arithmetic progression. Okay, so the people who actually didn't follow that, it's not that important. The proof, if you like to see what is the proof, but for the time being, you need to know how to use the formulas. Do you know when the lesson ends? I always forget. 55, okay. Okay, so let me just give an example here. Okay, so what is the sum of the first 20 terms of the following sequence? Okay, this is a very standard and simple question. What is the sum of the first 20 terms of the following AP? So the AP is given to be minus 21, minus 16, minus 11, and minus 6, and continues. It's a very simple and a standard question. You have some exercises like this in the book. So what should we do? First of all, I want you to understand what is the point of the question. They are asking about the sum, and they are asking about the first 20 terms. So this means exactly what they are interested in is S sub 20. So I want you to understand that this is the question they are asking about. Okay, we have two formulas for Sn. Which is more useful, do you think, here? The first one or the second one?
First one?
The first one, because for the second one, you need to know a number 20. Of course, it is possible. If you are patient, you can calculate a20 first and then use the second one. But it would be better if I just directly use the first one, because the first one depends on n, depends on a1 that I have, and depends on d. Of course, finding d is very simple. Yes? Okay, so the first thing that I do is to find d. D is the number minus 16 minus the previous number, which is positive 5. And then what I do, I would write Sn is equal to n over 2 times 2a1 plus n minus 1d. This is the formula. I write it in front of myself to see it. And then I know that the question mark is S20. So this means that 20 is playing the role of n. So this becomes 20 divided by 2. 2 times a1, I can read it from the problem, it's minus 21. And again, this n is the same n that appears here. It is 20 minus 1. And then I multiply it by d, which I found to be 5. And then I calculate this. Whatever I get is the sum. Okay, so 20 over 2 is 10. This is minus 42. And this is a 95. Yes, 20 minus 1 is 19. 19 multiplied by 5 is 95. And if I add these, it becomes 10 times, what is this? It is 53. So the answer becomes 530. Yes? Okay. I think I have to continue the lesson a little bit later because it might be you're tired. So yeah, I will stop here, but the lesson is finished according to the book. So on the Google Classroom, I can write which pages to read and which problems to work. But I will continue a little bit with arithmetic progression, and then we continue to geometry. Any questions? Thank you very much.